Hi guys, welcome back. We are going to talk about Chapter 1, Section 4, angle measure today. So hope you are ready to take some great notes and work some examples. Here we go. This is Section 4 of Chapter 1. You need to add the following terms to your definition section. Alright, so now that you've added those terms, let's go ahead and work example 1, naming parts of an angle. So if you'll go ahead and draw an angle with me here. So let's just draw a ray, and we saw that when we have two rays that meet at or that have a common endpoint. So let's go ahead and move this guy. They have a common endpoint. That will form an angle. All right, so here's our angle. Let's go ahead and label our angle. Let's name the vertex where those two rays meet A, and let's go ahead and put a point on a ray, and then also the one at the bottom. So I have ray AC and ray AB. When we name rays, we start at the endpoint and name them. That way, when we notate, we can start here. Now, you can name it backwards and draw the ray backwards, but usually you'll see them like this. All right, so I'm going to go ahead and put a 1 there. This angle can be named angle A, because when I name this angle, you know exactly which angle I'm referring to. If there were another ray coming off of A, then we would have to name it with 3 letters. And when we name it with 3 letters, the vertex is always in the middle. So there are 3 ways that you can name that angle. Notice there's a 1 on the angle, so you could also name this angle, angle 1. All right, sides of the angle, like I said, are rays. So I have ray AB. I also have ray AC that both help to form that angle. All right, so I'm going to let you try one here. Let's go ahead and draw. So you can draw with me. And let's label this SRT. So I have ray RS and I have ray ST that are opposite rays. They meet at R, they have R in common, and heading in opposite directions. This is angle 1, 2, and 3. And then I have ray RP and RQ. All right. First, name all the angles that have R as a vertex. Name all angles that would have R as a vertex. So you should have named angle 1, angle 2, and angle 3, or you can name with 3 letters, angle SRP, angle PRQ, which would be this angle, and then also angle 3 could be named as angle QRT. Right, there are my 3 angles and 3 different ways to name them. Now, you could also name angle SRQ. Angle SRT is actually a straight angle. Angle PRT. So there are several other angles that we could name as well. Angle SRQ, this angle here, the straight angle, angle SRT, which measures 180 degrees, and angle PRT. All right. Let's talk about classifying angles. In your definitions, you wrote down how to classify angles. We have right angles, angles that measure 90 degrees. Looks like an L when you make that, or when you see a 90-degree angle. It will look like some type of L. It doesn't have to be in this form. It can be turned as a V, but it will make an L shape as you rotate your paper around. So you can look for that. Also noted by this right angle. A lot of times as we're working through problems, we don't want to just look at an angle and say, oh yeah, that looks like it's 90 degrees. We'll either have to measure it or they'll have to tell us that it's 90 degrees. All right, but as we're classifying these angles, we'll just kind of walk through some examples here. All right, an acute angle, that's me. An acute angle measures to be less than 90 degrees, so I'll let you go ahead and draw an acute angle here. See if I can get that off there. There we go. An acute angle measures less than 90 degrees, so you can kind of compare if we think about making it an L with that bottom ray. This would be less than 90 degrees. So this is an acute angle. And then an obtuse angle would measure more than 90 degrees. So in your definition section, if you would like to write just little picture examples with your definitions, that would be a good idea. This is more than 90, and it's obtuse. All right, let's work an example here. We have ray BC. And another ray BE, and ray BD, and ray BA. All right, question for you. Angle ABD. Angle ABD. We can tell by looking at that one that it is an acute angle. When we measure this, we measure with a protractor to make sure that angles, if they're kind of close like this EBD, we would measure that with a protractor. We think it's 90 degrees. We would measure with a protractor, putting the hole of the protractor here and lining it up with 0 here, and then going around the marks to make sure that this is 90-degree angle. All right, let's look at angle ABC. Angle ABC is obtuse. We know that that angle is greater than 90 degrees. All right, notice the vertex is in the middle when I name those angles, and I can't just say angle B because you wouldn't know which angle I was referring to. All right, add these two to your definition sections, congruent angles and angle bisector. All right, let's draw another angle here. So we will label these. I'm going to see if I can get these a little bit better here. We'll just put dots there. That'll close the gap, hopefully. All right. So let's go ahead and name this MP, and then ray PN, and then ray PR. All right. If you remember when we talked previously that when I have marks like this, that means that the angles are congruent, or they are equal in measure, right? That makes PN an angle bisector. Ray PN bisects angle MPR into two equal angles. So MPN, angle MPN, and angle NPR are congruent, or they're equal in measure. All right, so let's talk about some things that we could be asked of problems like this. If angle MPN is equal to 2x plus 14, and angle NPR is equal to x plus 34, find x, and the measure of angle NPR. All right, so MPN, this angle, is 2x plus 14, and NPR, this angle, is x plus 34. We're supposed to find x and the measure of NPR. Well, because these two angles are congruent angles, they are equal in measure, which means since we have their measures, even though it's an expression, we can set these two guys equal to each other and solve. So solving that equation, subtract x from both sides. Let's get our x's to the left, and let's get our numbers to the right. So x is 20. They also wanted the measure of, that little n means measure, the measure of angle NPR. So I will plug 20 back into the expression for NPR, and that tells me that angle NPR is 54 degrees, which means also MPN is 54 degrees. And you could also tell me MPR is 54 plus 54, or 108 degrees. All right, that's it for today. I will see you guys soon. Good job, guys.